Hello students, now I want to show you how to make the first exercise with ANSYS Workbench. Before you can start the program, please follow the instructions for the installation. You can download the charge-free student version via internet under this link. After installation and starting the workbench will open. And now we want to create our first example, the backward facing step. You can see a screenshot of the backward facing step here and the detailed geometry with the dimensions on the lower part of the page. After the correct installation, you see the following screen of the ANSYS Workbench. On the left side you have a toolbox with analysis systems, different component systems, we will need this later, design, exploration like Six Sigma or the design of experiments fields, and you can also do external connections. But here we want to concentrate on a fluid dynamic problem called fluid flow with the tool CFX. You go to the analysis systems and then you drag the fluid flow problem onto the project page, and it will build up a full path of all the tools you can use. So you don't have to use a part component system anymore. After you've done this, make sure that you save your case on the file system. Go to File, Save As, and then you choose a directory, for example here under folder of your lectures, and please call it Lecture001 backward facing step, and then go to Save and save the problem on hard disk. Now you have to do 5 different steps. At first you create the geometry. After you have created the geometry, you create a numerical mesh. I will explain what a mesh is, I will explain it a bit later. Then you have to choose Setup, Solutions and Results. Now first go to Geometry and use the right mouse button to open a menu. Under the menu, please choose the Design Modeler by choosing the button New Design Modeler Geometry. Press the left mouse button. Then you have to wait a while, and please don't click too fast if you have to wait a bit, because all the different programs have to open and sometimes they need some time for opening the big files. Now I want to shift this menus a bit to the top. Okay, and now you see the Design Modeler. Design Modeler is more or less a cut tool to create and to sketch a geometry. And on this design tool you have a lot of features, but we will go slowly through the different features and explain what you can build, what you can do. On the left you have your tree outline where you build up your model, and you can also sketch geometries where you can sketch lines or rectangles or circles. Now go to Modeling, and before you start to sketch, use your mouse a bit. Try to learn how to rotate the mouse. You rotate while pressing the mouse wheel, or you can zoom zoom in, zoom out with the mouse wheel. Okay. And now we want to start a small sketch. To do it, we use the mouse wheel to zoom in until you have on your ruler on the button about 1 meters. Now we start building our step from the backward facing step. To do it, you have to choose a plane. Click a bit around, choose different planes, and then you can choose the XY plane. XY plane, let's have a look at the exercise again. Here we have X, Y, and Z is in the dimension of the document here. So we choose the XY plane. Now we start our first sketch. We go to sketching here and we start building a line. Now don't mention about the dimensions, just start to build up your first line, and if you press with the left mouse button on line and you go to the screen, you see a little pencil tool, and now you press with the left mouse button to start sketching your first line. Now this is the first line. You can again use to pressing the mouse wheel to look carefully at your line. Now go to the left bunch or to the right bunch of the geometry until it's highlighted in red colors. Now you can press again the pencil and draw a second line in -y direction. Again, left mouse click, you have your second line. Now again go to the bench until it's highlighted in red color. Go to left mouse, draw the line, press again left mouse, go again to the bunch, press left mouse, draw your next horizontal line, and so on until the geometry of your backward facing step is finished. So now make sure that you always close the lines against each other. There shouldn't be a hole between a bunch. Now you've sketched the first sketch. You can go back again to modeling, and when you now could go to the XY plane and open this plus here symbol, you see the sketch. If you finish the sketch, please press generate to finish it. You can rotate. Now you have your first lines, you have your first sketch, but you do not have a block. Let's look again on the exercise. Here we want to have a block. Now go to extrude, and you can extrude your block. Let's have a look again at the dimensions, and let's take 50 centimeters, half meter. Press generate again, go to extrude and type in 0.5 meters, again generate, to get a block of half a meter. Okay, that's fine. Your first geometry is finished, but you see the lines look a bit not really in the right angle. So you can go back to sketch, modify, drag. Now you can drag the lines a bit until they are more rectangular. this, but you see the dimensions are not really realistic. But never mind, we will come to this point later to fit the dimensions in the right way. You can do it with the dimensions dialog, but we will do this later. Before we go on, we want to start a small simulation and look if the model is alright. Press generate again. It doesn't matter if you press generate more often, no problem. Now the geometry is nearly finished, and this is our geometry of the backward facing step, but one thing is missing. You do not know where the inlet or the outlet from the fluid is, and to define this, we go to modeling, and now here at the upper border there are some filters to define faces. We go to this defining faces button, we press it, then you go over a plane, left click until it's highlighted in green colors, and then right click. Then you define named selection, press apply and press generate. Now you have your first named selection, but we need another named selection. We need a named selection at the end. Go again to selection filters, left click on this area, right click, choose named selection, apply and generate. Now we have our second named selection. Named selection at the left side and named selection on the right side. Now we want to define and change the name of this named selection by right clicking and rename, and we want to rename it inlet. The second selection should be named outlet. So now we have an inlet where our fluid should enter the step geometry and the outlet where the fluid should exit. Our model is now finished. Please close the design modeler and make sure that the green tick is on the right side of the geometry that shows you the geometry is finished. Now go to the mesh. Now we want to create the mesh by right clicking and pressing edit. Now the meshing tool will open. Please take your time, let it generate the meshing tool. It will take a while and you have to wait a bit. The program mesher opens. Your geometry can be seen on the screen. Now you go to the meshing tool and you see in front of the meshing tool is a small flash, and this flash indicates you that the mesh is not really finished. So we go to generate mesh, press it, and your mesh will be generated. It's a hexa mesh. We see cubic cells. It is your coordinate system where you can solve the Navier-Stokes equations. Also check the named selection inlet and outlet. Okay, it looks good. Maybe the mesh is a bit coarse. We can go to sizing and make it a bit finer. Again, generate mesh, and now you have more cells. But the cells are quite easy. We have cubic cells. In later lectures we will learn how to change the mesh to other mesh types. but now this should be fine for our first exercise. You close again the meshing tool, and please make sure that the green tick is on the right side of the mesh and that the mesh is loaded and everything is fine. After the mesh is done, you can go to Setup, and here again with the Setup tool you press right button and Edit. Now our third simulation tool will open. Yeah, takes a while. Let's wait a bit. Now again you have your third tool. It's called CFX Pre, and you see the geometry of your backward facing step here. And if you press on CFX CMBD, you also can see the mesh in green highlighted lines for all the cubes. Here you can't change the mesh again, can't change the geometry, but in the CFX Pre tool we have to define our fluids we want to use, and we have to define our boundary conditions we want to use. First we define our fluid, our material. Here on the left side, on the outline, we have some points where we can define the model, and there we have the materials button. Here in the materials button we can choose which material we want to use. There are a lot of materials like air, aluminium, copper, juice, water, steel, and so on. We can also import more materials, but now we just want to concentrate on water. So we go to default domain, right click, edit. Now we come to our default domain menu where we can define the whole simulation setup. First we want to choose a fluid. Default settings are air at 25 degrees centigrade. So we change it. We go to water. And once you've chosen water, please always press the apply button. So if you just close the menu, he will not take the material water. Okay, you can also change other things like temperature or turbulence model, but up to now it's enough if we have the right fluid, water. Now we go to OK to close the menu. Now we have to define the inlet, where the fluid enters. We go to Insert, Boundaries, Boundary 1, and we rename this to Inlet. And the boundary type now is a new boundary type called Inlet, and he will find a location on your geometry. We can also choose Outlet, but the plan was to choose Inlet to define where the fluid should enter. Additionally, we have to set up the boundary details. Now have a short look at our exercise. It's given 0.9642 cubic meters per seconds should be chosen. Okay, so we need a mass flow rate, and we choose (694.2) kilograms per second, which is the same as in cubic meter because of the density of water is about 1000 kilograms per cubic meter. Now Go to OK. And you can see something is missing here at the bottom. If you have this red error messages, you can just go there, double click, and okay, there's a problem. We need always a dot. Let's look again at inlet. Please don't use comma. Always use dot as comma, as decimal separator. Now we need also boundary condition outlet. Go to outlet and choose the outlet, and as outlet boundary condition we just use 1 bar outlet pressure. So that's fine. Now everything is defined. You have defined the temperature, 25 degrees, you have defined your fluid, water, and you have defined your inlet and outlet boundary conditions, and we have a default domain. You just can rename it to wall. If you check it, double click wall, now you see where the walls of your step are located. Okay, up to now that's enough. It's fine. You can close the model and check that the right green tick is highlighted here on the setup. And now we can go to solutions and do the numerical simulation of our fluid flow problem. Go to right click and just go to the point update with a small yellow flash, press update, and then you can let the simulation run. This will take a bit time. If the computer is not the fast, time can be longer. To check how the numerical simulation is running, you can now right click on solutions and open the display monitor tool to see whether your simulation is running. I maximize it. So let's wait. Show you a bit. Here you see. This is a residual. These are the numerical residuals of the Navier-Stokes equations. You can check it, but with this simple example, nothing should go wrong. Everything should be solved in a proper way. So I close it. If a problem occurs, you have to start read this. Points it's right. We can do this later. Now press the cross. Your simulation is finished. The solution is here. And now you can go to results, edit, and our result tool is a bit like a graphic program for sketching or for diagrams, and you can make visualization of your fluid flow problem. This is a really powerful tool. You can do a lot. You can visualize the fluid flow, but at the beginning I want to start with a really simple feature. You just entered some stream traces, and please remember the lectures I gave you in fluid dynamics. The stream traces I used, streamlines I used to show you the velocities and to visualize the flow. I press Insert, OK. Then you have to tell the program where to start your streamlines. I started at the inlet, of course, and you choose here velocity, that's fine, and you go to apply, and then you see your streamlines of your first fluid flow simulation, and you can also see how fast the velocities are. Here you see 4.4 meters per second. Oh, it's a realistic value. And what you also see, you can see that you have, after the step, after the backward facing step, there's a region of turbulence, and this is something that is realistic, that should occur in such a simulation. And I think you finished the first exercise successfully. Okay,